Okay, so I mentioned that I'm going to make at least a couple of modifications that's going to help the design, and then this becomes revision. So on the one hand, this hasn't really progressed past revision 0, pre-production, prototype, concept, whatever you want to call it. However, we go up through those orders. So I don't know that I have to actually give it a revision level, but I did start a drawing, and I haven't documented where I'm at in that level. So or in that process to have a revision level. So one of the things that I mentioned was I was trying to get this to where it would slide over a turnbuckle and make it integrated into the adjustment. Well, the cable is going to kind of come over and clear, so I need to see how much room I have over here to either one of the threaded links, or to have like a 50-pound carabiner, rated carabiner, be able to go through that geometry. So that being the case, I'm going to pick a hole size and 1/2 inch to start, and I might be able to get a slot in there. Yeah. I'm gonna switch it over to a slot. So as far as our geometry, then, if you I'll make this available if you want to replace the assembly because of the naming and the item tracking SolidWorks uses. I think it should load right into your part files, but I would say make a backup copy, or or copy your drawing into this folder rather than overwriting everything you've done so far, just in case. All right, so if I go to 0.25, that would be 1/2 inch. Probably not going to need to be that big, so if I were to go to 0.19, let's see if we can find a decent number. Now I pulled it on the angle, mainly because that gives me a good starting point. Let's go with I don't know how much I'm going to need to move that. I'm just going to go, missed. We're going to kind of pick an arbitrary 0.43. I'm not worried about it getting into or being tangent to this edge, and or deformation. And then in that case, 8 millimeters, 5/16, 0.31. That would be okay, and the cable is still able to go. All this is giving it relief so that I can get whatever my connection is in there and have it come up tangent to those points. All right, and then I'm a big fan of symmetry. So in SolidWorks, the design portion, anything that I can make symmetrical, and since we're only making a couple of these, having that extra operation to open this up doesn't add any significant cost. So if I mirror those entities and then grab the 2 slots, the nice thing about the slot is all of the geometry included in the slot is kind of a macro. So when I pick one, I'm picking them all. All right, so this just went into the layout. This hasn't been built into any parts yet. So this is where it goes up in complexity a little bit, is I need to go back and find my first plate and edit the part. And then there's just the boss extrude. Right, so I don't know if I'm going to keep these. So this is still kind of in that concept level. Oh, I need to actually show the layout. So right-clicking on the layout and hitting show. Then now I'm editing the part. I'm editing in the context of the assembly. When I open up a sketch, I should be able to pick, hopefully. All right, so maybe not through the part. I think that's a setting. We'll have to go find. Let's see if we can pick through the transparency. Nope, it's still trying to grab. All right, so some of the background operations, if you want to work with it, if you hit tab in an assembly, it hides geometry, so it hides the part. And so that will take me down maybe to the next level. All right, so I'm still looking for that spot where I can select my geometries without picking something else. All right, I'm going to go ahead and hide that too. So select, select, and then at the end I'm going to convert all of that geometry in because I still want a single point of reference, a single point of failure. All right, so when I come back to the plate and tell it to show, let's go expanding out the display, which is the same as, I think, hitting F8. F8 expands and contracts the display. Oh, it only picked, oh, that's neat. All right, I thought it would convert everything in. All right, maybe I don't want to do that. So it got everything. Interesting. All right, select chain it is. Let's see if that brings it all in. All right. So I guess I haven't tried to convert slots into a top-down assembly. So select chain, and convert, and then we can show, and F8 to collapse. All right, so there's my view, and that should give me enough to extrude cut. And I'm going to tell it to go through all. All right, and the selected contours. Well, it shouldn't be contours. It should find its way. Check my direction. Check my cut. See what the error contains. More than one open contour. So, either that or duplicated entities somewhere in that mix. So I go back and do a little diagnostics. All right, so apparently I did not erase one of those, and the little gray, everything looks good. We'll try one more time. Nope. How many times did I hit? So not that one. I really don't want to go through and delete all of these. So, and I don't think it lost any endpoints. All right, we're going to see what it'll do if I pick the regions then. So through all, selected contours. It's got to be duplicate entities somewhere, so that'll open up the slot. So I'll pay a little better attention when I do the next one. That gives me enough relief on the plate. And then I'll hide, and we'll show the plate 2. All right, and then editing plate 2, we go back in, edit the part. So let's see if that one's going to allow. No. So I need to dig in the options and find that whole selection through the parts. All right, so selecting chain grabs all of the geometry. And we'll see if we can do it without duplicating anything this time. Convert the entities. Oh, I'm not in the sketch yet. Oops. All right, we'll try that one again. Shift tab brings the parts back. And then it would help to actually open up a sketch. All right, so we'll go through and pick up the geometries and convert. All right, that one looks a little bit better. And then I can hide or show my sketch or show my part. Features, extrude cut. Let's see if this one. So this one gives me the preview. So I definitely was a picking issue. All right, we'll accept. I think we're in pretty good shape there, so I can hide the layout. All right, so the next thing that I'm not entirely sure of, let's go ahead, and if you haven't used isolate, so isolate pretty much turns everything to a hide condition except for the entity. I think I want to have some fixturing holes on this, but I'm not exactly sure where just yet. So that would be another modification, that when I get this to size and have potential clamping, that I have either prepared for that fixture or some method to hold this down so that I can go completely around the outside. All right, so coming over to the little isolate that pops up, I can exit the isolate and bring it back. All right, so in the process of doing that, we save, and the only two pieces that really changed were plate 1 and 2, and we'll rebuild and save the document. And then I'm going to switch over to my drawings. All right, and then I mentioned that after class we kind of noticed that the logo isn't staying or didn't come over, so not really sure what's going on there. But if that's the, I want to say it came over on the first one, and it's definitely not there. So we'll do a little more diagnosis on that one. So, all right. So first sheet is still the assembly. If I was going to put in a revision block, like I said, I don't know in my document control that I've actually reached a level of review or of being in a production that it needs a revision. But if I needed a revision, then we would come up to, and looking right at it, now we got the revision cloud. So let's just go to tables since I'm not seeing it. And under tables, we can add a revision table, and we can make templates for the tables. So revision symbols, shapes, and the locations, and it will give me a table such as, so a little bit on the large side. And then this is referring back to sheet 1. I could go ahead and fill that in, say added the slots, the date, the approved, and go from there. All right, so that's more for future reference. And then since the slots did not pick up any geometry as far as our center marks, all right, I'm going to be in the center mark. Let's go ahead and place them for the slots, and then notice that the slot center marks have the ends, the center. Basically, how do you want to define the location? So if I go with just the slot ends and document details, this needs to be on the center lines, or on the center, well, and really it didn't find any slots. Okay, in that case, guess we're going to pick. Oh, and then probably still need to put it on center. Really, you're ignoring that. Well, we'll see if it builds out. Interesting. All right, so I'm just going to go through and pick those, and I will force them over to the center location. All right. All right, so I make a revision. I have to go back and pick those numbers up, and we'll see if we have enough room to locate. All right, so this is kind of the other reason that I was just going to do this as an example more than giving you the geometry to have to go through this process. All right, so it works out with the angles, some number, and some additional number. And because these aren't that critical, let's see, I didn't pull those all the way across because we're already starting to get a little complicated. So let's see what it looks like if we start pulling that geometry. So I have my datum. All right, so here's my concern: is the more extension lines, the more geometry that crisscrosses this part, the more kind of convoluted it's going to get to figure out what's going where. Especially if we print this out and we print it out as a black and white, laser print, and it doesn't have that level of detail. This is going to be kind of hard to read. So in this case, it might be worthwhile to go with the 2 times, or we make the assumption that since the slots are symmetric, they carry over, right? But we need to have some dimension, some form or fashion to locate those geometries. All right, so I'm going to give myself a little more room. And this is one of the things that I like about the ISO version, where the dimensions are vertical. Doesn't really affect readability, but it makes it a little bit easier to, did not want a 90. A little bit easier to place the dimensions. Okay, so if we go this route, then we have to make the assumption that it carries all the way over. If we go to the, oh, missed one. And if we go to the full extension lines, then we have to kind of contend with all of those extra lines, extra geometry going across the part. All right, so I think that's busy enough. On the sheet 4, then I'm going to change tack. All right, so if you're at this point with from the previous, then you don't have to go into the ordinate. If you want to try the ordinate, I will give it to you as an example, and you're welcome to adjust. But basically, I need to get rid of all my dimensions because we're going to go into Smart Dimension, and I'm going to come over to Ordinate, so I don't really have to think about where we were pulling from. Oh, I didn't get my. All right, so I'll pull the base 0. And let's go ahead and carry these all the way across so we can see what it looks like. I do need my center marks. And if I hit enter there, I think that's just going to kick it out. So, all right. So place. Okay, so that gives me the slots. I need to switch those over to the correct layer. All right, so with an ordinate, since I got out of the ordinate and need to get back into it, then I can right-click and say Add to Ordinate, and we're going to go through and just pick all of those elements. And to the height. All right, and so we need to jog just a little bit. They're starting to run into each other, so if I grab that dimension and don't get too carried away, it will kind of jog the dimension away. All right, and then my next, the horizontal and the vertical ordinates, you can pick those specifically. I think it's easier just to go to Ordinate Dimension and pick the line for the reference. And let's see, I got out of that one, so Add to Ordinate. And working across the drawing now. Oh, now I did that again. All right. So my habit is to dimension, and then kind of the assumption is that it carries across the part unless it's specified otherwise. All right, so this makes it a little busy. I mean, with the colors, it's readable, but I don't think it's as readable as maybe just leaving the geometry just on the one side. So those are decisions that we have to make and pick up from a baseline dimension to an ordinate dimensioning scheme. All right, so let's see, we did not, I thought we added a couple of symbols, maybe not. Okay, so the question on this one became the V, and if I need to control it, so let's go ahead and save the document. If I need to control it as a GD&T, is it a critical dimension? And the answer is probably not. I can dimension this with standard and give it a plus minus location. My measurement strategy, or suggested measurement strategy, would be to put an 1/8 inch pin in here and measure for center, and then measure it at a couple of points around the part to verify that we got to location. So this would help to have a, find it here, a detail view. So under the view layout, going into the detail, I am going to attach this to the V, and now I have detail A. And detail A at 1:1 doesn't really give me anything useful. So let's take a look at 2:1. All right, so quite a bit bigger. All right, so first thing I'd want to control is the angle. Well, the angle in this case is kind of a function of the tool, and depending on the manufacturing process, if this was set up on a lathe and we're plunging into this V, then it is going to be the accuracy of the grind on the tool, or the location when we touch it off, if it's CNC, or when we touch it off manually, moving over to centerline. So 60 degrees with our standard notation, I think that gets a plus or minus 1 degree for the machined. You know, that's pretty generous even on that small amount. And then the location, let's see, we have a datum. I picked the datum to be the bottom side of the part. So I'm going to stay with that as the reference, and then go to centerline. And so we had 105, which is the half of the 102, or 210. Don't know where I got that one out, reversed it. All right, so the 105, and then that tolerance could be a little bit closer than just the plus or minus 5. All right, so if I wanted to set that as a symmetric dimension, then we go over to its value, and the tolerance precision becomes a symmetric, and location plus or minus 2 thousandths. Right, so I just have to enter the one value, and it will give me that symmetric or bilateral dimension. And then position-wise, I'm not sure where I like that, so we'll place it. All right, so that not only makes it a little bit bigger, a little more readable, but it gives me a chance to elevate that tolerance. And so, from a GD&T standpoint, you know, position, the angularity, I could use it, but the question becomes: is it adding value? Is it something that I need for this part? And right now, the answer is no. All right, so this will give me you know, a tolerance that I can inspect to, that I can measure to, the 60 degrees. What I don't have then is that internal geometry. So since this is going to end up being a diameter, I want to say we're going to come down to the V, if it'll let me have it. There we go. And even though this becomes a linear dimension, it's probably the most readable location. All right, so that goes to 3.671. The problem is inspecting for it. So I don't know that that's any better than saying from the outside to the bottom of the V, so going from that silhouette edge to the V intersection, that's any better. From a manufacturing standpoint, I would rather see this number, because that's something that I can physically touch the tool to the outside and then watch the number go in, you know, making a depth of cut. So that being the case, if I needed a reference dimension, then I would come over to the location and look at the dimension text, and I can put the parentheses around it, and that becomes my reference dimension. Right? So I don't know if that helps. You know, so that's a to be determined if it stays. All right, so that will get me kind of the next level on this one. Like I said, I probably want to put some kind of fixturing, some kind of geometry for clamping or otherwise. So that's as simple as a couple of 1/4-20 or a clearance for a 1/4-20 screw to be able to clamp this in place and make those geometries. All right, so complete, not quite complete. We're at that next stage of a jumping off point, and coming over to sheet 3, then we have all of the tolerances of all of these geometries. Then there isn't anything in here really that can use the positional tolerance. It would be nice, but when we think of these being at 3/16 with the the basic square tolerance, this is something that's going to have to be analyzed further. So the location and the relation to the through bore isn't as critical, because as long as we hit the 375 and the pin goes through and it captures the bearing correctly, then this can kind of move around within that 5/1000 tolerance zone without any significant issue. These can move around depending on the clearance. So these were the 190 through. So they're fairly tight tolerance to a number 10. So that tolerance is probably too tight. If we have that movement, so that would be one that would come up for analysis. All right. So as we're going through this level of the print, we're going to start looking at what happens when we get to our maximum material conditions, our least material conditions, and if we have established these as datum A and datum or datum A on the flatness, and then the datums B and C on the perpendicular faces, how is that going to relate to our positional tolerance on the 4 holes? Right. I think the machine can get there, but have I made these too tight as I'm going through that process? All right. So on this part, I'm going to kind of stay with because it's symmetrical, it doesn't really matter which side I put the flatness on. I don't really care about parallelism, because when we come back to the assembly, right, this surface and this surface are fairly critical to be flat, and the pulley flatness and parallelism to the outside is fairly critical. But this outside surface could be kind of ugly, scratched, not very wavy, roughness, whatever, and it's not going to really matter. As long as I can have the clamping force of the screw into the threaded hole to hold these together, I'm not so concerned with these outside surfaces. All right, and because they're symmetry, it's not really one that this surface is more important than this surface. If it wasn't symmetrical and it had to go together a certain way, then I would be more concerned with the process and which one I picked. All right, so we're going to give I grab the dimension. We're going to go over to the tolerance and pick the flatness. All right, so straightness, it doesn't really help me to just go in linear distance. We really need flatness over the length of the part. So we'll place it and then drag it into position. And I have flatness of the 2000, should be a matching tolerance to the pulley, right? So when I drag that feature control frame away, I forgot where did it go? Thought I put 2000s in there. Okay, so when I drag it away, then that becomes now the form tolerance to establish that face. All right, so our next pass when we come back to orientation and position is going to be the slots. I already know that the 4 slots are not critical. They're going to be big enough. They're going to accept the geometry. There isn't really an issue with balance. I just need to be able to have clearance. So that's something that's missing from the dimension, is that I need a radial or a diameter, a width, and a length. So I could do 0.38, and then going between the arcs, 0.31. And because all of these I can either say 4 times, or I need to apply typical. All right, so since this is going to apply to each of the items, then we'll go 4 times, and the 380 can be 4 times. Yep, I want to do that. There we go. All right, so have geometry with dimensions. It has a reference. The location, in effect, the 310, because of our dimensions to the center marks, in effect, the 310 becomes a reference dimension. The 380 gives us a width that isn't controlled by the centers of the arcs, the center of locations. So in that case, I may want to change this to a max so that it's easy to inspect to. So on the leaders, I can go to a max and a max because I selected those arcs. If I had selected between the points, then I'm not going to get that max condition. So 380 by 690, and if I make that a reference dimension, that will give me something that I can quickly measure and see if it's within the tolerance zone. And this may even, as we go through the analysis, these may even go to 2 decimal places. They don't, you know, they're not as critical to the function of the part. Okay, so another pass. We have a little more control over the surface. And then positional, I have to decide what's critical between the bearing and the 4 holes. I think the 4 holes are critical within their pattern, but not so much to the distance of the part. Oh, and I still missed one. I wondered where those dimensions went. All right. So we'll open up a little more room. And since I did it on the Ordinate, and we're kind of comparing these anyway, we'll go ahead and put in the baseline. And I'm starting to get a little tight on the space, so I don't really want to center these, and I don't want to get them too cluttered up to where I lose the readability. All right, but then again, I can't have it stretching all the way across the page, losing that much readability as it goes. All right, so a little more complicated, another little level in the evolution. So kind of the same thing here. We have the 4 times 159 for the 1032. This is the other side of our positional tolerance. So when we look at the tolerance zone between these 2 parts, that's going to be our critical analysis. That's where we're going to see, is the 190 with a 1032 that probably measures 186 to 190 too tight of a tolerance. So yeah, more than likely it is. All right, so same thing. I'm going to pick the width of the slot, and then go to 380. And then again, if I was to just pick the line, I'm not going to get a max condition. And since I want that condition more for reference than anything, let's see, is that going to give it to me? I need to get a little closer. All right, so once I get a little bit closer, it gives me the linear distance, and then I can switch over to its leaders and go to a max condition. and we'll set the value, and we'll give it a 4 times. And I think this time I'm just going to copy, so Control C on the keyboard, and we can come down and do a Control V. And I know we had one pop up that was modifying the dimension. Be careful modifying the dimensions. So as long as you don't disturb the less than, whatever the system modifier is, so the dim, and the greater than symbol, we really shouldn't be into affecting those numbers at all. All right, so missed the thickness, so we need a 0.25. And then we're back to the GD&T. Now, one of the things with the symbols, if we do this stack up, I should be able to copy. So picking the flatness of 2000s and hitting Control C, and coming over, and I'm not sure if I have to pick the edge or not, but it probably doesn't hurt. When I do the Control V, it's going to come in attached to it, and then I can drag it into position and get the flag, get the form control onto that surface. All right, so between the two, I'm leaning towards the Ordinate because this has gotten complicated enough, but you know, still everything kind of crisscrossing there, it looks a little busier than I would like. So if I can make the assumption that it's coming across, yeah, I'm not sure what a best practice there is. We're going to have to decipher that one. All right, so since the other one was a reference dimension, I want to put that one in real quick. We'll add the parentheses and have it for reference. Okay. So we need to go to this one. We have the 220. We did a stack up already that said our bearing had a upper limit of 220, I believe, and then the largest that the pulley could get at 210 was 215, and then the smallest to get would be 205. Right, and then so that is kind of where the V groove would start to fail. Is the 105 is a little bit of a shift, you know, based on percentage, but we can come back to that one. All right, so cylindricity, circularity on this, probably at the outside, you know, whatever the stock material is at 3/8, I can probably live with. So if we were to go to even a 2 decimal place on the 375, that would be acceptable. The 190 through still has that issue with the 1032. We're basically creating a zero clearance fit if we do the stack up just right, and I get machine screws that are at 190, then putting it through a 190 hole, through a 190 spacer into a tapped hole, all of those holes have to be theoretically perfect. All right, so I think that number, as I analyze it or as we go through the analysis, that one's going to come out to be suspect. All right, so the flatness, this is a fairly small part. It should be relatively easy to hold, but I do want to make sure it's in the range. The 220, well, let's see, did I put a tolerance on the pulley is 210 plus or minus 5? Can I go to 220 plus or minus 5 and have this shrink to 215 and then the pulley go up to 215 and end up the surface is rub? All right, so going through that process, the other thing was the let's see, if I remember correct, I'll have to pull it up. The bearing was 7/32 in thickness, 0.21875 if you want to carry it out that far. So we had just the 2000s to adjust for the flatness, and now we're getting into the need and the reason for the analysis is we're getting enough parts and we're getting down to the last details that the next pass on this really has to include those stack ups and those virtual conditions, those worst case scenarios. All right, so to put on this, I'm going to give this a plus or minus 2. So I at least have some control over it, and this becomes a symmetric. And this may become a bilateral. So if that was the case, that's just going to make the tolerance zone tighter. If it went up to 222, all right, so another need for the analysis is we need a system or a chart or some kind of table that's going to say, if this grows this way, what is it? How does it affect the pulley and the rest of our geometry? All right, so let's go with the symmetric as a 002. Not 2/10. This part just got really expensive. Be grinding all day on it. And then for our flatness, we're going to be back into the geometric tolerance. Since I gave this 2, well, then because of the stack up, well, let's go ahead and do flatness. I'm going to have to stay within that tolerance zone with the flatness and the parallelism. So those are going to line up to about 1/1000th. All right, and I can see that I'm developing a habit of putting the flatness on the right. I'm not sure that that's going to be a good practice. So I'm kind of analyzing my motives and my my process as I go. Next one will be the parallelism. It will also be at 1/1000, and we can apply it to the part, and then bring it back to where it becomes the flag. No. Oh, that got the surface. I didn't want the surface. I wanted the edge. All right, so I have the arrow, and then we can pull that one up. So these parts are fairly small. It should not be that difficult to hold plus or minus a couple of thousandths with plus or minus 1. All right. So that gives us another pass. You know, taking this in stages. The questions, the remaining items that we need to look at, and I'm still primarily focused on flatness, parallelism, perpendicularity, things that are going to control form and orientation. All right, getting into the positions, we will we'll go through another level and then see where we can get to. All right, so what I'm still looking at. And so that one's a question mark, and where did it go to? And that one's a question mark. Stay over there. There we go. All right, so you can see, even though very similar parts, the readability and the visibility of the dimensions as you go through, you have to make those decisions if you're doing the detailing. If you're getting this print as a machinist or an inspector, you have to take into consideration the readability of this part and the numbers that you're going to deem critical to holding and doing the manufacturability. All right, so make sure to save this. All right, so the flatness and the parallelism, I'm going to try this analysis once more. This may get cut off the end if it doesn't work any better than it did last time. But I have 2 sketches. One sketch is my perfect form. So kind of reinforcing and going through that terminology is 1 inch by 2 inch. And on the pixel count, we're out to however many decimal places you want to call it. If you want to say that it's accurate to the angstrom, 10 to the minus 19, okay, the pixel count says it's, you know, accurate to angstroms, whatever. I can hide that one. So let's see, F8 does the display. If I hide that one, then I see its tolerance zone. And this is an exaggerated tolerance zone. So where we tried to do the plus or minus 5 or the plus or minus 2 to begin with, this is magnified by 10 times now. All right, so I gave it a tolerance zone of the plus or minus 50. And as we start to shrink that tolerance zone, what I'm hoping to see is that some of those values are going to get tighter and tighter on the controls, but are also going to be determined by the manufacturability of the part. So I need one more sketch, and to make this work, I'm just going to sketch from the min to the max. And then I don't want perpendicularity or horizontal, vertical. So I'm going to try and avoid those relations. All right, so if I get rid of the perfect form and hide that out, then within the tolerance zone, the idea is to play with, if, you know, like I said, with the magnification of 10 times, if this was only 5 thousandths, we would only be moving about that much. All right, so, and this being at the low side of the tolerance, our least material condition at the base, you know, this could also be at max and going the other way, but we pretty much have to pick one to start the analysis. So when we think about in terms of, you know, we've made this side flat, and so this is holding our plus or minus dimension, as well as having the flatness of 2 thousandths. So its tolerance zone, or you know, in this case 5 thousandths, our tolerance zone being 5 thousandths, we're right there at perfect form. So as the conditions, if I was exactly perpendicular, I would be at least material condition, and I would be using up the tolerance on the other side. And so within this little square, as we move around and it's able to pick up those items, if I go to another worst case, and I'm going to go ahead and let it apply the relation, then I would be 5 thousandths out on the perpendicular, and that would be 5 thousandths. But those aren't exactly parallel, because I wouldn't expect them to be parallel, because this one comes up to be vertical, and what's able to move? Oh, I didn't get that one. All right, so we can't move inside of the tolerance zone, but if this window is to move out, well, now we have the possibility that they're getting close. But perpendicular and parallel to each other, let's see what that would look like if I add the constraint and go to parallel. All right, it doesn't quite come to that point, and doesn't quite come to that point. All right, so I'm going to pull that one out, and Control Z one more time, and one more time. All right, so let's look at this side if it was to go to maximum material condition, or sorry, to the maximum of that tolerance zone, which would in effect be a fundamental shift back to the centers, back to perfect form. So if I measure that, I should get 2 inches with no zeros, or all zeros, depending on how you look at it. So I would be shifting over to the start point, and I would still be able to see those tolerances move. Right, so moving through and getting that visual is I can be that much out of perpendicular. This side can move independent, and this side can move independent as my worst case scenario progresses. All right, so one of the things I want to do with circularity then is play a little more with the ellipse, and we'll do that. I think I'll add a pin. So be aware that I'm probably going to move away from the shoulder bolt as the connection, and we'll make a pin that goes through that will just have a washer or a button head or a cap screw on the back side of it that's able to contain the pin into the bearing. All right, so I'm going to post this as a for the part file up onto Canvas. So kind of drag that around and move it, and that will kind of, as you're going through, well, let's see if we show the perfect form again, you're kind of seeing where it's going to line up, where those movements and those clearances and allowances start to come into effect for just playing with that geometry. All right, so we'll call that good for tonight. And, you know, again, we probably have next week to kind of finalize our prints. Hopefully I will have some time to make the plates, if not the pulleys. You know, ideally I would make everything, get some video of the manufacturing processes to build this part, and be able to kind of tie that whole concept together.